Good morning, students. We will wait for some time for your friends to join and then we will begin. Okay, students, so we will begin now. Welcome to this lecture on biochemical engineering, first chapter we are discussing. So, good morning to everyone. In our previous lectures, we were discussing about what is fermentation, what are the types of products formed, or the range of products formed, then what are the basic six components or segments of any fermentation process, then how was the fermentation evolved and where is it now. Okay, and as I was telling those things, we also saw the uh, yeah, we talked about clones, then we were talking about fermenters, the different parts of fermenters. Almost 19 parts were there, out of which six we studied or seven we saw in detail. Okay, so each part plays its own important role. It is good if you are aware of all the parts, and most of the parts of a fermenter will be the same as that of a reactor, a chemical reactor. Okay, almost everything will be the same. uh, One inclusion will be the addition of nutrients and addition of oxygen for the living organisms to survive. And I told you that there are several unit operations that take place while performing fermentation. And we have two main uh, processes in fermentation. One is upstream and downstream. Okay. So we are going to talk about these things today: fermentation technology, downstream processing, basics of fermentation and processing. So what fermentation basics are? So the product of a fermentation reaction can be either the cell itself, cell in the sense the organism which you are selecting. Sometimes you can keep the cell as your product. For example, if you're working on antibiotics and the antibiotics is inside the cell, inside the microorganism, then you want the microorganism alive. Okay, so this is referred to as biomass production. Okay, sometimes fermentation can result in a reaction where the cell itself is a product, and that is referred as biomass production. Next, a microorganism's own metabolite. Okay, and for example, you are looking for enzymes, you're looking for another set of antibiotics which is inbuilt of an organism, and it releases it out. Okay, if the product has come out of the microorganism, from the microorganism, then it is a metabolite. So a product can be a metabolite also, or the product can be microorganisms foreign product, referred to as a product from recombinant DNA. Okay, कुछ fusion करके या mutation करके trial and error जो करते हैं, so it can be sometimes a foreign product. So what are the three types of products? One is the cell itself, or the microorganism's own metabolite, or the microorganism's foreign product. Now we know these things: batch and continuous. आपने सीआरई में शुरू कर दिया होगा. सो अ बैच फर्मेंटेशन कैन बी कंसिडर टू बी अ क्लोज्ड सिस्टम. ओके, जिसमें आप एक साइड से इनपुट देते हो, जो भी आपको देना है इनपुट में, आपको रॉ मटेरियल देना है, माइक्रो ऑर्गेनिज्म देना है, ऑक्सीजन देना है, जो भी आपको देना है एक साइड से आपने दे दिया. फिर रिएक्टर क्लोज. इट्स लाइक द मूवी थिएटर. when you are entering the movie theater at 10 o'clock and आपने सब दे दिया, then the movie theater is closed. बीच में एक इंटरवल मिलेगा जिसमें आप यहाँ पे लोडिंग कर सकते हो, आपको अगर कोई फीड देना है दे सकते हो, बट इन बैच इट इज नॉट अलाउड. So whatever goes in at the initial stage itself has to undergo the reaction and it comes out at the final stage. So it is a closed system. At time t is equal to 0, the sterilized nutrients solution in the fermenter is inoculated with the organism and incubation is allowed to proceed. In the course of the entire fermentation, nothing is added except oxygen and acid or base to control the pH. So, except oxygen and these acid or base buffers, you're not going to add anything during the fermentation. This is the batch reaction or batch fermentation. Then the composition of the culture medium, the biomass concentration, and the metabolite concentration generally change constantly as a result of metabolism of cells. Metabolism in the sense the change that happens within the cells. After the inoculation of a sterile nutrient solution with microorganisms and cultivation under physiological conditions, four typical phases of growth are observed. We'll be talking about these growth phases in third chapter in detail, but still, ये growth curve बोलते हैं. वी हैव डिफरेंट फेसेस ऑफ अ माइक्रोबियल ग्रोथ कर्व. सबसे पहले लैग फेज होता है, एक्सपोनेंशियल फेज होगा, फिर स्टेशनरी फेज एंड देन डेथ फेज. It's just like our life cycle. How we are born, then we grow, then we are in a stationary 30s to 50s में हम stationary phase में जाते हैं, then we approach the deceleration phase और death phase. तो ये हम डिटेल में एक एक फेज के बारे में चैप्टर 3 में पढ़ेंगे. So these are the growth phases in short. They are telling you what is lag phase, what is log phase. So the lag phase is nothing but physio physico-chemical equilibration between microorganism and the environment. मतलब एक एडजस्टमेंट में आना. अब आपने माइक्रो ऑर्गेनिज्म को न्यूट्रिएंट में डाला, वो न्यूट्रिएंट खाएगा, लेकिन उससे पहले वो थोड़ा एनालाइज करेगा, ये न्यूट्रिएंट गर्म है या ये न्यूट्रिएंट ज़्यादा कार्बन रिच है, क्या है ये. तो थोड़ा वो एनालाइज करने के लिए जो टाइम लेता है उसे लैग फेज बोलते हैं. अब कुछ कुछ ऑर्गेनिजम्स अडेप्ट हो जाते हैं, एडजस्ट हो जाते हैं, चलो वो लोग बढ़ेंगे. लेकिन कुछ ऑर्गेनिजम्स जिनकी बहुत कम मेटाबॉलिज्म है, जो लोग बहुत वीक है, जो माइक्रो ऑर्गेनिज्म बहुत वीक है, वो मर जाएगा लैग फेज में. तो लैग फेज इज वन एडजस्टिंग फेज. देन कम्स द लॉग फेज, मतलब एकदम जबरदस्त ग्रोथ. A growth of the cell mass can now be described quantitatively as a doubling of cell number per unit time of bacteria. Doubling of cell number. Initially, अगर आपने 10,000 बैक्टीरिया डाले हैं, काउंट 10,000 डाला है, then at the log phase it starts doubling itself. It becomes 20,000. Then stationary phase. Now you are giving some raw material. It is a batch reaction. Okay, batch reaction में आप वापस raw material बीच में कभी नहीं देते. तो क्या होगा, जो भी रॉ मटेरियल आपने, जो भी न्यूट्रिएंट मीडियम आपने जो दिया है, उसमें जितना भी न्यूट्रिशन मिलेगा वो बैक्टीरिया खा खा के ग्रो हो रहा है. वो लैग फेज में तो, लॉग फेज में तो ग्रो हो गया. अब न्यूट्रिशन कम हो गया ना, तो एट सम पॉइंट ऑफ टाइम इट हैज टू स्लो डाउन इट्स ग्रोथ. तो इसे स्टेशनरी फेज बोलेंगे. As soon as the substrate is metabolized or toxic substances have been formed, growth slows down or it is sometimes completely stopped. Death phase. In this phase, the energy reserves of the cell are exhausted. अब उससे ज़्यादा वो जिंदा नहीं रह पाएंगे. तो ये चार phases हैं एक microbial growth के. And this is the fermentation or a fermenter, which we have seen in the previous uh, lecture itself. Fermenter parts kya kya hai. So you have an acid base supply here, you have this medium input, you have steam input, air supply is given, cooling water for insulation, thermal jacket is there, then steam and effluent are removed, you have a sparger here, then discharge of cooling water here, then sensors for temperature, aeration and pH, then you have control panel to regulate pump cooling water, pump air supply, acid base supply, and then you have pressure gauge here, and you have the final agitation system connected to shaft and impellers. Okay, this is how the industrial scale impellers, fermenters look like. So these are concrete based structures. And apart from this, you have stainless steel based also. Okay, so what is downstream processing now? See, यहाँ पे एक ओवरव्यू दिया गया है जनरल स्टेप्स इन डाउनस्ट्रीम प्यूरिफिकेशन. अब यहाँ पे वो आते हैं जिनका प्रोडक्शन हो चुका है, आपको अभी उसका प्यूरिफिकेशन या प्रोडक्ट रिमूवल करना है. तो यहाँ पे स्टार्ट होगा फ्रॉम द फर्मेंटेशन ब्रॉथ. मतलब फर्मेंटेशन हो चुका है स्टूडेंट्स. फ्रॉम द फर्मेंटेशन ब्रॉथ आप उसे फर्मेंटर से बाहर निकालोगे. इट इज इन अ लिक्विड स्टेट. फ्रॉम द फर्मेंटेशन ब्रॉथ you are going to take the cells and those that are having no cells. Okay, now this broth which is having cells in it, it needs to be separated further. Cell separation has to take place. This cell separation can be done by cell disruption, then debris separation and then precipitation. And ये जो लिक्विड फॉर्म का है उसे आप एक्स्ट्रा सेलुलर बोलेंगे. जैसे सेल है, सेल के अंदर कुछ प्रोडक्ट होगा, सेल के बाहर उसने कुछ प्रोडक्ट रिलीज किया होगा. अब जो सेल के बाहर है उसे इन द फॉर्म ऑफ लिक्विड आप एक्स्ट्रा सेलुलर रख लोगे, एंड जो सेल के अंदर जो है उसको निकालने के लिए आप ये सब स्टेप करोगे. देन फाइनली आपको दोनों प्रोडक्ट्स, एक्स्ट्रा सेलुलर हो या इंट्रा सेलुलर हो, आपको दोनों प्रोडक्ट्स कॉन्सेंट्रेशन करना है. देन यू गेट अ हाई रेजोल्यूशन प्यूरिफिकेशन स्टेप एंड देन पॉलिशिंग. ओके, एंड जो फर्मेंटेशन ब्रॉथ में बिल्कुल भी सेल्स नहीं है, एकदम क्लियर है, उसे आप कॉन्सेंट्रेट करके ले लोगे. ओके, फाइनली फॉर प्यूरिफिकेशन एंड पॉलिशिंग. What is downstream processing? the various stage of processing that occurs after the completion of the fermentation or bioconversion stage, which includes separation, purification, and packaging of the product. So remember, this is the after the completion of fermentation or bioconversion stage. Then stages of downstream processing. अब एक एक करके stages ये हैं. First you remove the insolubles, then do the product isolation, then go for product purification, product polishing, and then to the markets. Now, stages in downstream processing, a few product recovery methods may be considered to combine two or more stages. For example, expanded bed adsorption accomplishes removal of insolubles and product isolation in a single step. Affinity chromatography often isolates and purifies in a single step. तो ये कुछ examples हैं. हम separation techniques, advanced separation techniques आपके final year में आप पढ़ोगे. उस time आपको ये ज़्यादा डिटेल में समझ आएगा. Downstream processing is nothing but your separation technique. Okay, another name for downstream processing is separation techniques. And this is the overview of all the unit operations that is involved in downstream processing. For cell separation, you can go with flocculation, centrifugation, or filtration. If you are going for cell disruption मतलब उसे break करना, then you can go for homogenizers, then hydrolytic enzymes. अगर आप cell clarification करना चाहते हो, then go for centrifugation and filtration. If you are going to do concentration, then you can go for precipitation, chromatography, ultrafiltration, partitioning, distillation also possible. And some high resolution techniques are chromatography, electrophoresis, dialysis. And finishing and packaging involves crystallization, filtration, gel chromatography, drying. Okay, so I want you to make note of this particular slide. Don't take screenshot, write it down. Give the heading as unit operations in downstream processing. Write today's date. This comes under the first chapter itself. आपने ऑलरेडी फर्स्ट चैप्टर में कुछ नाम मेंशन किए होंगे, राइट? उसके नीचे आज का डेट डाल के ये हेडिंग डाल के ये वाला स्लाइड आप प्लीज नोट डाउन करो. एंड आफ्टर यू नोट इट डाउन, टेल yes in the chat box. So please make note of this and give me 2 minutes. I'll be back. Please make note of this till then. Okay, have you written? Shall I move ahead? Okay, so these were the unit operations that are involved in downstream processing. Next, there are some information on the separation of cells and medium. So recovery of cells or the medium, that is called clarification. For intracellular enzyme, the cell fraction is required. As I said, अगर cell के अंदर आपका product है, then you need the cell. For extracellular enzyme, the cell culture medium is required. तो अगर आपका इंट्रासेलुलर है तो आपको सेल चाहिए, अगर आपका प्रोडक्ट एक्स्ट्रा सेलुलर है तो आपको मीडियम चाहिए, जो ब्रॉथ है आपका जो बाहर है वो चाहिए आपको. On an industrial scale, cell medium separation is almost always performed by centrifugation. अब हम लैब में भी centrifugation ही करते हैं. Industrial scale centrifuges may be batch, continuous or continuous with desludging. हमारे पास यहाँ पे batch है. Then इन स्टेज बाय स्टेज हम देखेंगे कि सॉलिड लिक्विड सेपरेशन कैसे होता है फॉर फर्मेंटेशन ब्रॉथ. फर्मेंटेशन ब्रॉथ का मतलब वो जो फर्मेंटेशन के बाद पूरा खिचड़ी जो बन जाता है ना, उसमें सेल्स होगा, उसमें मीडियम होगा, उसमें वाटर होगा, उसमें सब कुछ होगा. तो जो आपका वो न्यूट्रिएंट ब्रॉथ है, ये जो फर्मेंटेशन ब्रॉथ है, उसको आप क्या कर सकते हो. फर्स्ट वन, फ्लोटेशन. Gas is introduced into the liquid, it forms bubble. Cells and other solid particles are absorbed and removed. Next is flocculation. Cells and debris form large aggregates and settle down. Addition of flocculating agents are also done. Filtration, most commonly used to separate the biomass in the culture medium. Then types of the filtration that are used are depth filters, which are composed of filamentous matrix. Particles are trapped in the matrix and fluid passes out. Absolute filters, they are of specific pore size than the particles that to be removed, and mostly used to remove bacteria. Then you have rotary drum vacuum filters, consists of rotating drum that is immersed in a tank of broth. As the drum rotates, it picks up the mass from which it forms a cake. Then you have membrane filters, which employs membranes to separate the filter medium from the cells. Then you have centrifugation. What is centrifugation? Which uses the force, centrifugal force, and it keeps rotating. Okay. And there are three types here also: tubular bowl centrifuge. Small, commonly used in pilot plants, can be run at high speed and can be run in both batch as well as continuous fermentation. Disk centrifuge, it consists of several disks that separate bowl into settling zone. Slurry is fed through the center. Then you have multi-chamber centrifuge. Modification of a tubular bowl centrifuge consists of several chambers which allow zigzag movement of the feed. Then how are the intracellular product released? Okay, so by physical method you can go for cell disruption. Cell को तोड़ के आप उसके अंदर का प्रोडक्ट लेना चाहते हो, then how is it possible physically? By physical means, how can you go for cell disruption? First is ultrasonication, high sound waves. Okay, very high frequency sound waves, that is ultrasonication. Then osmotic shock. Osmotic shock is nothing but pH, okay, used to separate hydrolytic enzymes and binding proteins. Then heat shock, thermolysis karna using heat. Then high pressure homogenization, mixer grinder mein mixing karna. Then grinding with glass is also possible. So what are the physical methods of cell disruption? Ultrasonication, osmotic shock, heat shock, high pressure homogenizer, and grinding with glass. For chemical methods, you can either go for alkali treatment, that is you give them alkaline solution जिसमें वो अपने आप को lysis कर ले, break कर ले. Organic solvents, toluene is very oftenly used. It dissolves the membrane phospholipids. Then you have detergents also. Titron X100 or Tweed is used. Then enzymatic method, lysozymes. And this is lysozymes are enzymes which are used to break the cell wall. Okay, most frequently used for gram-positive bacteria. For gram-negative, in combination with EDTA, it is used. EDTA is a cofactor, ethylene diamide triacetic acid. It is used. Then precipitation. What is precipitation? Forming of solid, right? So formation of a solid in a solution during a chemical reaction is precipitation. Solid formed is called the precipitate, and the liquid remaining above the solid is called the supernatant. तो यहाँ पे solution है जो एक जिसमें से आपको करना है, तो उसे सस्पेंशन में पहले लाओ, देन जो नीचे प्रिसिपिटेट हो गया एंड जो ऊपर रह गया. अगर आपका प्रोडक्ट एक्स्ट्रा सेलुलर है तो आपको सुपरनेट चाहिए, अगर आपका प्रोडक्ट इंट्रा सेलुलर है तो आपको प्रिसिपिटेट चाहिए. Then how is product purification achieved? To separate contaminants that resemble the product very closely in physical and chemical properties. It is expensive and it requires sensitive and sophisticated equipment. Then crystallization, process of formation of solid crystals precipitating from a solution, melt or more rarely deposited directly from a gas. Chemical solid liquid separation technique in which mass transfer of solute from the liquid solution to a pure solid crystalline phase occurs. So there is mass transfer happening between the liquid and the solid phase. Product polishing, it is a final processing step which end with packaging of the product in a form that is very stable, easily transportable and convenient. And it can involve crystallization, desiccation. Desiccation is nothing but drying out. Desiccation, then lyophilization and spray drying are typical unit operations that help in product polishing. Then lyophilization is one of the storing preservation technique जिसको हम detail में पढ़ेंगे. So this method is nothing but freezing the material, reducing the surrounding pressure and adding enough heat to allow the frozen water in the material to sublime directly. Sublime. What is sublime? What is sublimation, students? Okay, very good. It is already given here. If you can complete the sentence, it is already saying. So it is sublimed directly from the solid phase to gas. So these are the unit operations that are involved in your biochemical engineering, especially in the downstream processing. Okay, when I was in my biotechnology, when I was doing my bachelor's, my friends who were doing chemical engineering, वो लोग DSP नाम के एक सब्जेक्ट से बहुत डरते थे. DSP मतलब डाउनस्ट्रीम प्रोसेसिंग. डरते थे क्योंकि इसमें इतना ज़्यादा बारीकी से आपको एफिशिएंट सेपरेशन करना होता है. प्रोडक्ट फॉर्मेशन भी इतना ज़्यादा आप फोकस नहीं करते जितना आप प्रोडक्ट सेपरेशन में फोकस करते हो. प्रोडक्ट फॉर्म हो गया, अगर आप उसे एफिशिएंटली सेपरेट नहीं कर पा रहे हो, क्योंकि 100% कन्वर्शन तो हो ही जाता होगा. अगर अब डेफिनेटली 100% तो पॉसिबल नहीं है, एटलीस्ट 95% अगर आप सेपरेशन भी कर लो, देन वो बहुत इंपॉर्टेंट है, बहुत ही एफिशिएंट है. सो दैट इज व्हाई दिस सेपरेशन टेक्निक्स या फिर डाउनस्ट्रीम टेक्निक्स आर वेरी इंपॉर्टेंट इन एनी बायोकेमिकल या फिर केमिकल इंडस्ट्री. Okay, so now I'm going to show you a video which is on the fermenter parts, and then I have some video on coagulation. I'll show that also.
Microorganisms can be used in food production. We call this process biotechnology. There are two examples you need to know about in real detail. One is how yeast is used to make bread, and the other one is how bacteria are used to produce yogurt. Microorganisms are clearly very useful. We don't only use them to make bread and yogurt, but all sorts of products such as penicillin or insulin. Therefore, getting as many of these microorganisms as possible is really, really useful. The good news is that you can get loads of microorganisms if you grow them in a big container called a fermenter. So industrial fermenters are huge, large tanks that hold up to about 250,000 decimeters cubed of liquid culture of microorganisms. The conditions are then kept in perfect optimum levels for growth. The fermenter must first be made sterile. You don't want to grow the wrong type of microorganisms and again cause some horrendous disease. So the first thing to do is pump steam through the whole equipment at very high pressure. Then you can add your culture medium containing microorganisms and all the nutrients that they need to grow and reproduce. You have a little motor that are going to turn some paddles, which keeps the solution what we call agitated. It keeps it moving. We've got to keep it all mixing round. We then also put a water jacket around the whole thing. You can then keep it at the complete optimum temperature for growth and for the enzymes to work. Air is also pumped in to keep the organisms respiring aerobically. And there's special probes that allow us to monitor the temperature and the pH so the conditions can be automatically controlled by a computer.
Okay. Okay, so this is about the fermenter and how we are sterilizing first, then filling it, and then we are going to do the reaction. Now I have another video. Let me get it for you. Yes, the one which was in the center, that vertical thing was agitator. Now I'm going to show you a video on flocculation and coagulation just to make you understand what is flocculation and what is coagulation. This particular operation was done in water treatment, but you can relate the same with biochemical or chemical treatment as well, chemical processes as well.
In this lesson, we're going to be talking about the coagulation and flocculation process. And here I want to do a quick demonstration of just how coagulation and flocculation works. Well, as you can see, we have here negatively charged colloids in a jar that we might use for jar testing. Now, most of the particulate matter, or the non-settlable particulate matter in surface water, carry a negative charge with them. Well, what we do to neutralize these negatively charged particles is we add a coagulant, such as alum or aluminum sulfate. And when we add the positively charged coagulant, we end up neutralizing the negatively charged particles. And that coagulation takes place in about 1 to 2 seconds. Once the charges are neutralized, these particles can begin to flocculate together. And they start by forming what's called microfloc, and then as the coagulation process continues, they become macrofloc and become a size that can ultimately settle out. So by mixing these negatively charged particles, we can then get them to come together and then ultimately flock together. Well, once they come together, we then can add another chemical, polymer, and that polymer helps keep that flock together. And it bridges the microfloc to form a macrofloc that ultimately can be settled in the sedimentation basin. So the coagulation and flocculation process impacts the effectiveness of the sedimentation process, which we'll talk about in the next lecture. Well, here we have what's called a flocculator, and most flocculators consist of 3 distinct basins that are separated by baffles. And each flocculation chamber has a different mixing energy. And as you can see, in the stage 1 flocculation chamber, you have high mixing energy, where the particles are moving around very quickly. In the second stage, the particles have gotten bigger because they've flocked together or agglomerated, and the mixing energy gets lessened, so we have medium mixing energy. And the purpose of that is so we don't break the flock apart. And then finally, in the third chamber, we have low mixing energy, and that low mixing energy allows the flock to continue to get bigger, and form a flock that will be able to settle in the sedimentation basin. And as the flock gets bigger, we want the mixing energy to be less and less so the flock does not come apart. So notice here in this third stage chamber, we've seen the particles even get bigger as they attach with one another. This flock is now ready to settle in the sedimentation basin.
Okay, so that was about coagulation and flocculation. Coagulation is in which you are going to neutralize the charged particles in your medium by adding the oppositely charged. If your medium is having negatively charged, then you add some positively charged agent so that it goes in, it neutralizes the charge of the medium, and then they are ready to flock themselves. They are ready to attach themselves together. Okay. So coagulation and flocculation occurs hand in hand, one after the other, and they both are helping in sedimentation, जिसमें से आप अपना product या फिर cells को recover कर सकते हो. So this was about some unit operations that is happening in biochemical processes. So do you have any doubts in these unit operations, student? Anyone wants to know anything more on this? Yes, any doubts in this? Okay. सबसे पहले आशिफ आपको कोएगुलेशन करना पड़ेगा. कोएगुलेशन के लिए आप चार्ज न्यूट्रलाइज कर दोगे. अब आफ्टर द चार्ज इज न्यूट्रलाइज्ड, यू आर गोइंग टू अलाउ देम टू फॉर्म एग्लोमरेट्स. यू आर गोइंग टू अलाउ देम टू फॉर्म लम्प्स. एक दूसरे के साथ उनको क्लबिंग करने के लिए मौका देते हो, तो वो एक दूसरे के साथ आके अटैच हो जाएंगे. जो छोटे पार्टिकल्स थे अब वो बड़े होते जाएंगे. दे आर कॉल्ड एज फ्लॉक्स. उसे फ्लॉक्यूल्स या फ्लॉक्स बोलते हैं. दैट पर्टिकुलर प्रोसेस इज कॉल्ड फ्लॉकुलेशन. ठीक है. अब उस फ्लॉकुलेशन होने के लिए आपको अपना मिक्सिंग जो है, मिक्सिंग का आप जो स्पीड रखते हो वो कम करना है. So as the mixing speed decreases, the flocculation rate increases, and as the flocks become bigger and bigger, या तो आप उसके साथ एक पॉलीमर ऐड करो ताकि वो फ्लॉक्स वापस डिसइंटीग्रेट ना हो जाए, या फिर कभी कभी फ्लॉक्स अपने आप ही बहुत स्ट्रॉन्ग बाउंड हो जाते हैं कि वो जाके नीचे सेटल हो जाएंगे. एज द वेट इंक्रीजेस दे गो एंड सेटल डाउन एट द बॉटम ऑफ द जार एंड दे फॉर्म फ्लॉक एंड दे फॉर्म सेडिमेंट्स. Okay, Ashif? Okay, fine. So now I'll take the attendance. Just a minute. So now you can see the attendance screen. Okay, Vaibhav is present. Mohit, Vivek,
Yes, ma'am.
Ashiv present, Paras present, Mihir present, Mohit.
Yes, sir. Yes, ma'am.
Okay, those who have given attendance can leave the meeting. Thank you, everyone. Mukesh,
Yes, ma'am.
Kishan, Chakresh,
Yes, ma'am.
Rohan, present, Karmik, okay, Hussein, Parth, Giriraj,
Ma'am, 13, Hussain, present.
okay, Hussein present. 14, 15, 16,
Yes, ma'am.
17,
Yes, ma'am.
18, 19,
Yes, ma'am.
20, 22,
Yes, ma'am.
okay, 24,
Yes, ma'am.
25,
Yes, ma'am.
26, 27,
Yes, ma'am.
28,
Yes, ma'am.
29, 31, 32, 33,
Yes, ma'am.
34,
Yes, ma'am.
36, 37, 38, 40,
Present, ma'am.
okay, 41,
Yes, ma'am.
42, 43. Yes, those who have given attendance can
Ma'am,
leave.
26 present, ma'am. Hello.
Okay, Siddesh, you're present. 45,
Yes, ma'am.
46,
Yes, ma'am.
47. Okay, Rutul, Priyank, Parth,
Yes, ma'am. Present, ma'am.
Siddesh.
Yes, ma'am.
Okay, Prithvik is also present. Tarpan,
Yes, ma'am.
Uttam.
Yes, ma'am.
Okay, fine. You can all leave. Thank you, everyone.